Hi class, welcome to the section on exponential growth and decay model. For this model, we're going to be looking at the rate of change. The rate of change is very important to evaluate because the rate of change will tell us a lot about how it's proportionate to the rate of time. So when we look at the rate of change, it's denoted as this. It's proportional to this right here. When we look at exponential growth, quantity such that is every instant the rate of increase of the quantity is proportional to the quantity at that instance, we say the quantity is growing exponentially, or it's exhibiting exponential growth. P to t equals 3 times 3e to the 4 to the t power. We can look at, let c and k be any constants, and let y equals ce kt, then y prime equals the following. When we look at exponential growth and decay models, we're trying to look at how we can relate this concept and how we can relate functions. We can look at, in my example of the fruit colonies, and how important that is and how we can build on that as well. Because the building of fruit, or these fruit flies in a refrigerator in an area, is based off the model. So if we look at the world's population, 5.5 billion on January 1st, 93, 5.8 billion on January 1st, 98. At any time, the population grows to the proportion population at that time. In what year will we reach 7 billion? Excellent example that we can use. So we look at 93, that'll serve as our initial time. Time equals 0 at that point, and population is this in billions. 98, t equals 5, so just add 5 years, and it will be measured like this. So here's the formula that we're going to use. Let's see if we can figure this out. So the formula becomes this. Now we use all the other information to determine k. Here's our function so far. 5 years, 5.8. Rewrite it. Solve for k. So therefore, here's the equation that we use. Now we can determine when will the population be 7 billion. So if we have the derived function, replace p of t with 7, divide this, rewrite it, solve for t, 2011. So the graph is going to represent this as well. Excellent example of how we can do predictions in calculus. This is just one of the ways I wanted to focus on in this model. And if you have any more additional questions or need resources, let me know.